Hello, I am Sambhaji Patil. I welcome all of you for this session. So in this session we are going to see comparison between microprocessor and microcontroller. Okay. So once again I would like to welcome. So I am Sambhaji Patil. So we are going to see comparison between microprocessor and microcontroller in this today's lecture. So first of all we should know how to compare microprocessor and microcontroller. So basically this is the block diagram of general purpose microprocessor system, which consists of, this is a general purpose microprocessor, CPU, central processing unit, and which require externally RAM, that is a random access memory, ROM read only memory, IO ports, input output ports, timer, and serial communication port. So in case of microprocessor, these are RAM, ROM, IO port, timer, serial communication port is required externally, okay, because that is not on chip available. So RAM, ROM, IO ports, timers and serial communication ports are not available on chip. It is need to connect externally to the microprocessor, and also this can access with the help of address bus and data bus. So using address bus and data bus, we can access the RAM, ROM, IO port, timer, serial communication port. So RAM, it is a random access memory. It is like a scratch pad. We can write, erase. So writing on page using pencil, it is RAM. We can erase with the help of eraser. Writing on page using pen, ink pen, that is ROM, read only memory, we cannot erase. IO port, timer, serial communication ports, we need to connect externally. Then in case of microcontroller, we can see there is a single chip, and on that single chip there is there is on chip central processing unit, arithmetic logic unit is also there, RAM, random access memory, ROM, read only memory, IO port, timer and serial communication ports. These are available on chip. Okay, it is single chip. Now in case of microprocessor, these are the general diagram. Okay, ALU, instruction register, program counter, registers. So microprocessor, it is a programmable digital electronic device which contains CPU in a single IC package. CPU means central processing unit. Microprocessor is a general purpose device used in many applications, and microprocessor is generally using to do arithmetical logical operations. ALU, control unit and registers are there, which are using to perform addition, subtraction, multiplication, division, comparing two numbers, okay, fetching of data from memory and IO devices. Okay, so these are on chip available, the CPU, RAM, ROM, IO port, timer in case of microcontroller. But in case of microprocessor, these are not available on chip, we need to connect this externally. Okay, so these are the comparison between microprocessor and microcontroller we can see. So microprocessor, it is a general purpose processor. Microcontroller, it is specific application controller. Microprocessor, it does not contains RAM, there is no any on chip available, RAM, ROM, IO ports, these are not available on chip. Okay, it contains no RAM, ROM on chip, we need to connect this externally. In case of microcontroller, it contains on chip RAM, random access memory, ROM, read only memory. Random access memory, it is using for temporary storage of data. Read only memory, it is for permanent storage of data. Here is read and write operation is possible in case of RAM. Read and write, both operations are possible, but in case of read only memory, there is only read operation possible. Once we write, we cannot erase. Okay, read only memory. IO ports on chip itself available, because in case of microcontroller 8051 there is 4 IO ports, port 0, port 1, port 2, port 3. But in case of microprocessor, suppose we consider 8085 microprocessor, we need to connect external IC, that's 8255 as a power port to access port A, port B, port C. Okay, So on chip input output ports are available in case of microcontroller 8051. The size of RAM ROM can vary in case of microprocessor, but it is fixed because it is on chip. In case of microcontroller, makes the system bulkier. It is very compact microcontroller. It is more expensive microprocessor, less expensive microcontroller, and this instructions we can handling. There is a less bit handling instruction. Here is more bit handling instruction. These are important points. This you have to note down and you have to remember. And here is one important thing is there. The microprocessor is best architecture. There is von Neumann architecture. Von Neumann means there is a program and data memories are stored in the same memory. The program and data stored at the same location. Okay, but in case of microcontroller, there is Harvard architecture. There is program memory and data memory is separate. Here is a program memory, data memory is same. In case of von Neumann architecture, in case of Harvard architecture, program memory, data memory is separate. Okay, then here is important points which is written in instructions is available in like this format. So you have to remember this at least 8 points. In examination you require there 8 points to remember, and to get this question is for mostly for 8 marks or maybe for 6 marks. Okay, so that you have to remember the points. Okay, you have to remember one more important point is there. Von Neumann architecture in case of microprocessor, because the program and data memory which are their same program and data memory location, because where we are writing a program there we are saving the data. But in case of microcontroller there is Harvard architecture. We are writing program at another memory location and storing data to the another memory location. So program memory, data memory is separate. So due to this program memory, data memory is separate, there will be what is happening, instruction execution time. Okay, the execution time will be very less because program memory, data memory is separate. So that's why execution time is less. Here execution time is more because where we are writing a program there we are saving the data. Okay, so execution time is very less in case of Harvard architecture. With von Neumann it is more, and there is a separate program memory, data memory is there in case of Harvard architecture. So there is also pipelining is possible. Pipelining means when instruction execution is there, then execution, okay, at the time the another data operation also possible at the same time because it is separate. If it's the program memory and data memory both are separate, the ones where one operation is going on simultaneously another operation also we can do because there is separate memory locations. Here is same memory locations, so at one time one operation is possible. Okay, so that is pipelining is not possible in case of microprocessor, but pipelining is possible in case of microcontroller because Harvard architecture program memory, data memory is separate, and due to that pipelining architecture, pipelining operation is possible. One, there is execution. Okay, the fetching, decoding, execution. This is 3 operations: fetching, decoding, and execution. When decoding is going on, another instruction fetching going on. When execution going on, another instruction fetching going on. That is because of that pipelining is also possible, and due to that there is a simultaneous operations because same there is different program data memory and execution time will be less. Okay, so these points you have to remember. So this some example given: desktop PC, okay, and digital cameras 8051. Okay, these are some examples are given. Okay, so I am Sachin Sambhaji Patil. I am very thankful to all of you for watching this video. Okay, please like my video and share the channel.